Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn more on the theory on how to write good clean code. So first of all, what exactly is clean code? Now there are many definitions for this. For me, it simply means writing code that is easy to understand and easy to modify. With bad code, you need to look at it for a real long time to try and work out what on earth that code is doing. Whereas with clean code, the intent of the code should be immediately obvious. Everything is very clear and straightforward and requires no effort to understand what exactly it's doing. That's the goal. The most important thing is simply following a good set of naming rules like I covered in the previous lecture. Always choose good descriptive names for all your variables, all your functions, classes, and really anything. If you just do that, then your code will be infinitely higher quality than someone who does not follow any naming rules. Beyond that, here's some more general guidelines. Starting off with a simple one, try to avoid magic numbers. These are numbers that are used directly in the code with no context for what exactly they mean. Like for example in this code, this one has a bunch of numbers, and just by looking at it, you can't really tell what those numbers are supposed to mean. After studying the code for a little bit, you might be able to tell that, for example, over here, this is supposed to be the super bonus damage amount. And for example, over here, if you see an if testing if the distance is under 5, and if so, call the attack, then probably this means this is the attack distance. And over here, testing if the distance is above 10, then go to jump, so this should be some kind of jump distance. So it requires spending some time in order to understand what the code is doing. So by using magic numbers, it obfuscates what the code is actually doing. So instead of this, we can improve this code by quite a bit by simply defining proper named local variables. So over here, just define an int for the super damage amount multiplier. Just set it to 2, and over here, instead of that, just use this one. And now it is very clear what exactly this line of code is doing. Same thing over here. Let's define an int for the attack distance. And over here an int for, let's say, the jump distance. And yep, so now the code is much more clear, much more understandable. You can literally just read this and it makes perfect sense as if it's in proper English. So if the distance is under the attack distance, you attack. If the distance is above the jump distance, you jump. Super simple. So with this, there's no need to waste any brain power trying to understand the code. All of it is immediately understandable. Another simple one is how you should never ever use strings as identifiers. Strings are terrible as identifiers because they make it extremely easy to make all kinds of mistakes. For example, look at this code. Over here, I'm using a string identifier in order to find the name of a child object. And here in Unity, you can see that this code actually throws an error. It throws a null reference exception. Here the code is doing a transform.find to get the child sprite, then goes, gets the sprite ren and changes the color. So quick question, can you spot the error instantly? And I'll give you a hint, the error is actually not in here. The error is actually over here in the editor. So again, can you spot it? And the answer is no. I know for certain that you cannot spot it because the error is literally invisible. Here in the code, I'm looking for a child that is named exactly sprite. And here in the editor, it doesn't look correct. Over here, looking in the hierarchy, it does look like it has a child named sprite. However, if I go in the inspector and I click over here on the name, yep, look at that, that's the issue. It turns out that this child name, this one has an invisible space at the end. So the code is indeed perfectly correct. There are no compiler errors here because everything is correct, but it is looking for a child with this exact same name, just sprite. And since the actual object has an invisible space at the end, it does not 100% match the sprite name identifier. This exact mistake is something that has happened to me several times and drove me insane every time it happened. Or here is another example. Look at all of these strings. So can you quickly at a glance tell the difference between all of these? It probably takes you a little bit because visually they all look quite similar. But identifiers are case sensitive, so looking quite similar does not matter. If it is now 100% exact, it will not work. So if you had an object with any of these names and you accidentally mistyped or wrote any of these other names, if you did that, you would get an error and you would not know what exactly is going wrong. Whereas if you don't use strings, like for example over here, I've got a variable named player10, I construct a brand new player and I call some kind of function on the player. If I use this instead of using a string, if over here I mistype, like for example, I change this one into a lowercase l, which looks quite similar, but right away the compiler tells me there's an error. So with this, I can fix the error without ever needing to run the code. Strings should pretty much only ever be used for text, so use them to store the player name or the name of some kind of object, but never ever use a string to identify an object. If you need to identify an object, use a direct reference or some kind of strippable object or an enum or a tag component, literally anything except a string name. Now, as always with every rule, there are exceptions. Sometimes, especially when working with things like web development, that usually involves a lot of JSON and some simple HTTP text requests, sometimes you really have no choice and have to use some kind of string identifier. In those cases, you should still avoid strings whenever possible. If you need a string to define some type of data, consider defining a constant and never use the string itself, only use the constant. If you do that and you mistype the constant name, the compiler will tell you. But basically, try to avoid using strings as identifiers at all costs. Then, one extremely important principle in writing good, clean code is the concept of managing complexity. That's really the main difficulty as you write bigger and more complex projects. The difficulty is in successfully avoiding becoming overwhelmed by managing that complexity as the project grows. And for that, your best tool is called information hiding, meaning for any code that you write, like a class, you should only expose as little as possible in order for the class to be usable. For example, specifically in Unity, a lot of Unity tutorials target at beginners teach you to make every single field public, but this is absolutely a terrible code practice. I made an entire video on this subject. By making it public, it makes this field easily accessible in the Unity editor, which is usually the goal. However, it has a side effect because it makes it also accessible from any other script. Now, for a beginner, this might sound like a good thing. You can easily access anything from anywhere. But that means that every single class in your entire codebase, which could be 1,000 classes long, every single one of those could potentially access and modify that field. So as you write your code, you have to constantly keep in mind that scenario, so that's a lot of wasted brain power. So like I said, the simple but extremely important guideline to follow is simply only expose as much as you need to and no more. So do not default to making everything public all the time. Instead, default everything to private and only use public when absolutely necessary. If a field is only ever used in that class, then there's no reason to make it public. It should always be private. That way, when working inside of this class, you don't have to keep in mind the entire codebase. You can just focus on this one single class since you know for certain no other class can ever touch any of these fields. You could have a project with 1,000,000 classes, but if this field is marked as private, then it does not matter. Nothing else can touch this field other than this class. Same thing for functions. If you have a function that is only ever used by a single class, then keep that function private. Do not make it public. If you do, then some other class in your thousands of classes, some other one could call that function, which could cause some unintended results. And if there is some kind of field that you need to access, instead of making it public, consider instead keeping it private and simply exposing some functions to get it and set it. That way you have a lot more control over how the underlying field is modified, and you can even add some logs over here if you need to. Alternatively, properties work as well. You can make it a property and add some code in the getter or setter. I cover properties in a lecture in the intermediate section. So in general, whenever you write a field or function or anything, always default to making it private. Only switch to public if you absolutely need to. Just following this one simple guideline will help you limit how much access different pieces of your codebase have towards other parts of your codebase, which in turn helps you minimize the total number of connections, which in turn helps you manage complexity even as the project grows. One great principle is the single responsibility principle. This means that each class or function should do one thing and one thing only. So if you have a game and you have some kind of player class, you probably should not keep any kind of enemy logic directly inside that class. That should probably exist in a separate enemy class. Same thing for functions. Each function should do one thing and one thing only. Don't write 1,000-line functions that do 10 different things at once. One good heuristic for seeing if a function is too big is simply if the best name that you can come up with contains the word and. If so, that probably means that function is doing more than one thing and would probably be best split into separate functions. Another related one is to keep your functions short. So this kind of follows the same as the previous principle. If your functions only do one thing, they will probably be quite short. If they are big, then chances are they are doing more than one thing. But this is also a very adaptable guideline that you should adapt to the situation. For example, in my game, Dinky Gardens, I have quite a few relatively large functions. Breaking those apart into smaller functions would actually make the code hard to understand instead of easier. So all of these guidelines do depend on the specific use cases, but on average your function should be relatively short. If your program is mainly composed of 500-line functions, chances are there's some room for improvement. Remember that refactoring is your friend and a perfectly natural part of the process. Another good one is group logic together, meaning, for example, let's say I have some stats in my player class. I've got these in my player class, and let's say I've got some sort of UI class that I want to display these. Since these three separate fields, these are all really part of the same thing, these are all player stats, instead of working with three separate fields, instead of having to, for example, call some function on the UI that takes in three separate parameters, instead of that, consider making a custom type just to hold these stats. So something like player stats, that inside contains all those, and then you would simply have a field, just one field of type player stats that contains all of the player stats. That way, data that belongs together is actually together. This simplifies things and makes it quite easier to understand. In terms of comments, the guidelines are the ones that I already mentioned in the comments lecture. In general, you should avoid using comments. If you need a comment, before you actually write that comment, see if you couldn't just rename some variables to make the code intent a bit more clear. In most cases, well-written code is going to be self-documenting, but at the same time, comments can be useful if your code is already extremely clear, but you'd still like to provide some extra information on something, like for example, why you're doing that code or how that function should be used. Another good one is simply called dry, or don't repeat yourself. Basically, if there's some code that you need to run 3 times, you probably should have a dedicated function instead of copy-pasting that code 3 times. Although remember, these are just guidelines meant to help you, so don't look at these as some unbreakable laws. In general, code should be unique, although sometimes you might need to copy-paste twice in some scenarios, that's fine. But if you find that you need the exact same code copy-pasted 3 or 4 times, chances are that's a signal for some refactoring. And speaking of refactoring, this is an extremely important process that you should be doing at all times. Refactoring is the act of rewriting or reorganizing code to keep the code quality as high as possible. This is a very, very important topic, and there is a dedicated lecture on refactoring in the beginning of the intermediate section. So these are just a handful of nice guidelines to keep in mind to help you write good, clean code that will help you a lot as your projects grow in scale and complexity. Although also, do keep in mind these are just guidelines. They are not holy rules that must never be broken. The ultimate goal of all of these guidelines is to help you achieve your goals. Always remember that. It is always up to you as a programmer to figure out when to follow the guidelines and when it's okay to break them. There are some people that follow some specific code rules so rigidly that it actually makes the code worse, so don't be like that. Follow these guidelines, which will help you in most scenarios, but also always be willing to adapt to the specific code you're writing. Now on this topic, personally I'm a huge believer in writing good, clean code. If you're a regular on my YouTube channel, certainly you've heard me talk quite a lot about it. The reason why I love it so much is because I spent a lot of time writing a ton of code where I did not care about code quality. I've been writing code since I was 10 years old, and I really only started being very careful with the code that I write since I was something like 25. So I've already suffered quite a lot because of code that I would write with some nonsense variable names or some obscure acronyms, and then later on when getting back to that code, I would have no idea what I wrote or how I could expand upon it. Because of that, I really hope to help you avoid the suffering that I went through. If you are a beginner, I hope you can start off on the right foot by focusing on writing good, clean code right from the start. If you do that, it will help you learn faster and grow your skills by a massive amount. Now, if you're looking for some more info on this topic, there are tons of sources to learn from. The one that I highly recommend is the book Code Complete. Reading this book alone massively improved my code skills by 100-fold. It really is that good. It's a pretty massive book, it's over 800 pages long, and it's all really technical. So it takes quite a while to get through it, but if you do read through it and you fully understand everything, if so, you will come out the other side an excellent programmer capable of building any program or any game you can think of.